So just as we use the Pythagorean theorem to find missing side lengths in right triangles, we also can use the Pythagorean theorem to determine if a triangle is a right triangle at all. This is called the converse of the Pythagorean theorem. Formally, this says that if A and B are measures of the shorter sides of a triangle, and C is the measure of the longest side, and C squared equals A squared plus B squared, then the triangle is a right triangle. And then also if C squared does not equal A squared plus B squared, then the triangle is not a right triangle. Again, this is the converse of the Pythagorean theorem. So here we have a triangle, and we have the side lengths of A, B, and C, where A and B are the shorter side lengths. We have 3 feet and 4 feet, and 5 is the hypotenuse. That's the longest side. So pretend like we didn't know this was a right triangle, but we know that A squared plus B squared equals C squared, or C squared equals A squared plus B squared. But that also confirms that it's a right triangle. It's almost like if you didn't have this right angle symbol, it wouldn't matter. We would still know that that's a right triangle based on the sides, because we could use the Pythagorean theorem. We could say that 5 squared is equal to 3 squared plus 4 squared. We've tested this multiple times. This is a Pythagorean triple. But the converse says you don't need the little symbol. You don't need that right angle. You just need the measures of the side lengths to know for a fact that this is a right triangle, that you are allowed to have the symbol there. So in other words, you can check to see if a triangle is a right triangle by seeing if the Pythagorean theorem is true. So to test the Pythagorean theorem equation for the given values of the sides of the triangles, you would see if the simplified equation is true, then that means the triangle is right. If the simplified equation is false, the triangle is not right. So we have our steps to a problem like this, where if the problem is asking, is it a right triangle, we would write the equation, that Pythagorean theorem, A squared plus B squared equals C squared. We would then plug in the numbers, or substitute in the numbers, square the numbers, simplify both sides, and see if they are equal. Let's take a look at an example. So here we have, do the following side lengths of a triangle form a right triangle? And we're given the side lengths of 8 inches, 17 inches, and 15 inches. So this is asking, do these side lengths make or form a right triangle? So we need to use the converse of the Pythagorean theorem. We'll start with the Pythagorean theorem, A squared plus B squared equals C squared. But now it's not telling you which value is the hypotenuse and the legs, and we don't have a diagram or a picture, and we don't have that right angle to mark the hypotenuse, see which side is across from it. So the most important thing with these problems is to be able to identify what are the values of A, B, and C. So a good trick or thing to remember is that C is always going to be the longest side, so that will be the biggest, largest number you have. So with 8, 17, and 15, we have that C is going to equal 17 because that's the largest number. Then A and B, it doesn't matter which one is which, because again, you're testing if those are legs, and it wouldn't matter which one is which in that situation. So A could be 8 or B could be 8, it doesn't matter. A could be 15, B 15, it doesn't matter. We just have to make certain for sure that C equals 17 because that's the largest number. So now actually writing the equation, we have A squared plus B squared equals C squared. If we plug in or substitute in the numbers, we have again, A is 8, B is 15, and C is 17. So A squared is 8 squared, B squared is 15 squared, and C squared is 17 squared. If we actually square those numbers, 8 squared is 64, 15 squared is 225, and 17 squared is 289. If we simplify both sides, 64 plus 225 is equal to 289. The right side was already 289 and they are equal, so that means yes, those side lengths form a right triangle. So you can use this converse now to see if any 3 side lengths form a right triangle. You just have to test the Pythagorean theorem and see if it's true or not.